Okay, so for this problem here, again, we're asking for the domain and the range. And I'm going to tell you should worry about two things. You should worry about, first off, it's a fraction, and you know you can't have a fraction with 0 in the denominator. So that tells you right away that x can't be 7. So x equals 7 cannot be in the domain of your function. Okay? So next, let's look at the numerator for a minute. It has a sort of an interesting thing there. You have to worry about that radical, right? We're going to take the square root of numbers, and I want to get real numbers back. Let's clarify that. We're not going to allow imaginary ranges. If that's the case, then what can't we use? Well, could we use 5, for example? Sure, because 5 minus 4 would be 1. The square root of 1 is 1. Everything's fine. We could use 6 even, or some number like that, because 6 minus 4 is 2. Rad of 2 might not be a rational number, but it's still okay. We're still getting back an answer. We can't use something like 3, because 3 minus 4 is negative, and therefore is not in the domain. How about 4, though? Well, if you did 4 minus 4, it'd be 0. The square root of 0 is just 0, and that's okay to have. So I can start to write my domain down. I know that we can start with 4, and 4 is included. And here's where I got to be careful. See, because a typical mistake here, someone might say, oh, 4 comma infinity. After 4, you can plug in anything you want. But don't forget about but the fact that x can't be 7. So we're going to say 4 to 7, put a parenthesis on the 7, because that means 7 can't be included. And then the numbers beyond 7, we can still include those. Those are okay. So what we write is union 7 to infinity. Okay? So now what I want to do is start to talk about range. And what I'm going to say to you is that sometimes range is easier to do by looking at the graph. So I'm going to do this problem first by looking at the graph, and then afterwards maybe we can reason out why the range is what it is. Okay, so if you have your calculator with you, you guys have 89s, so it'll look a little different. You guys are going to press diamond F1. I'm going to press y equals on mine, and we'll get to here. Okay? All right. So in order for you to type this in correctly, I'll be careful of your parentheses. I'm going to say open parenthesis 2 times the square root button, which on my calculator is over on the left, but on yours, I think it's above the multiply sign. I think you do second multiply. X minus 4, close. So I've closed my square root. I'll get out of that square root there. And then I'll close the numerator. And then I'm going to hit divided by, open, x minus 7, close. Okay? All right, again, when you type yours in, take a good look at it. It should look exactly what it looks like on the paper when you wrote the fraction, because you have pretty print on your calculator. And in terms of a window, I'd like us to all start with Zoom 6, Zoom Standard, and we'll see if that's going to be a good window or not. You're going to press F2, which is the Zoom menu, and then go to Zoom 6. I'm going to press Zoom in the middle here. I'm going to go to Zoom 6. And that graph ends up looking something like this. So what I want to start to do is start thinking about, hey, what y values am I getting back? Okay? So to do that, what you can do is you can press the trace key. For you, I think it's F3. And first off, you'll notice x equals 0. Notice that there's no y value next to that. And I claim we're not surprised because our domain didn't start until x equals 4. So if you want, you could just press 4, enter, and you get 0. Everything seems fine, right? Let's move to the right a little bit, and you'll notice I continue to have some y values. And then I'm going to start to have an issue around x equals 7. Because we know at x equals 7, there's no y value. So if you want, press 7, enter, and you'll notice there's no y value. Okay? So this is going to be new to you, but here's what I'm going to suggest. When you know you have a number like x equals 7 that's not in the domain, and you see this function, if you look at this picture, it looks like it's dropping off drastically before 7. It looks like the graph is going down very far in the negative direction. sometimes it's good to plug in numbers that are close to 7. So I'm going to recommend, for example, 6.9. I type in 6.9, that's close to 7, and then I'm going to see what the y value is. So go ahead, type it in, you'll see 6.9. You'll see a y value of negative 34 point something. Now that's pretty far down, right? I'm kind of curious, does it stop there or does it go down further? So if we want to find out what happens, we can get even closer to 7. So let's try, for example, 6.99 and see what happens. Hit enter. And you'll notice now I'm at negative 345. This thing's starting to go down really far, isn't it? As a matter of fact, if I put in 6 point and then 1, 2, 3, 4 nines and hit enter, I get back negative 34,640 abouts. So this graph is dropping off dramatically, right, as I get closer and closer to x equals 7 from the left side. Okay. So if we're going to attempt to draw an accurate picture of this thing, one thing we could do right away is we can say, okay, 1, 2, 3, 4. We can put a solid dot. We can start there. And then here's 5, 6, 7. And we know for a fact the graph does something like this. As it gets closer to 7, it drops off more and more. Okay? So let's continue by looking at the other side of x equals 7. So here's our graph again. Now, just by looking at the calculator, you can see that on the right side of 7, it looks like the graph is going up really, really high. So again, I'm going to ask you to pick numbers that are close to 7, but this time that are just on the right side of 7. Here's what I mean by that. 6.9, 6.99, and so forth. Those numbers were on the left side of 7. Now I want to pick numbers on the right side of 7 that are close to it. So I'm thinking of numbers like 7.1. Enter. Ooh, I get a y value back of like 35. Let's get closer. 7.01. And I get something in the 300s. 7.3 zeros and a 1. Oh, it's 2 zeros and a 1. All right, we'll do that first. We're into the 3,000s. And what I'm starting to suspect now is that as we get closer and closer to 7 now from the other side, what we notice is this graph starts to climb really, really, really high. Okay? So we're doing pretty well here. We know that our range is going to go down all the way to negative infinity, and we know that our range is going to go up all the way to positive infinity. What we're not sure about now is what happens in between. You see, when I look at this calculator, it looks like this graph on the right-hand side is coming down and getting close to the x-axis. But it may not be. Okay, so what we need to sort of rule out here is, or try and figure out is, what is this graph doing on the far right? So I'm going to recommend we change our window. So on your calculator, I think you have to do Diamond F2. On mine, I'm going to just press Window. And I'm going to go to X max. And I'm going to change that to a bigger number. I'm going to say maybe 50. We'll start with that, and we'll see how things look. And then just press Graph. In your case, Diamond F3. And we'll look at this picture, and we'll try and decide, hey, is this thing leveling off at the x-axis, or is it leveling off someplace else? So I went to 50. Sure, it looks like this graph is coming down and flattening out. I'm going to press that trace key again and see what happens. Okay? On your calculator, I think you just press regular F3 for trace. And I'm going to hit the right arrow. And as I hit the right arrow, what I notice is the decimals I'm getting back, here's like 0.4 something, 0.3 something, and so forth. These things are getting smaller and smaller and smaller. It looks like it's getting close to 0, right? Does it seem to be equaling 0? No, but it seems to be getting closer and closer and closer. Okay? So for the time being, what I'm going to say is if you want to just be a little bit more sure, we can press Window one more time. We can go to X max, and we can try something like maybe 150, and press Graph again. And we'll see that most of the graphs squished up on the left. But if we hit trace now, we'll notice our y values are even lower than they were before. Before we were getting like into the high 0.3s. Now we're in the 0.2 somethings, and then eventually it's going to drop down below that before we get here. If we type 150, enter, we get back to y value of 0.16. So it seems to me like this thing is getting closer and closer to y equals 0. Okay? So for a little while I was worried that something was going to be left out, where it turns out that 0 is going to be okay. The graph's coming down and getting really close to 0 from above. We know it hits y equals 0 on the lower portion of the graph. So what we can say is that our range is -infinity to infinity. So we sort of lucked out here in that sense. All right, so we're going to talk about domain. Clearly, x can't be 8. Everything else is going to be fine. There's no square roots to worry about. So we can say -infinity to 8 union 8 to infinity. That means every number that works except 8. For range, though, we need to consider something else. Okay. So one thing you could do is look at the graph, and what you'll notice is when you graph this thing in a calculator is that, well, I actually already graphed it. There it is. It seems to start slightly above the x-axis over on the left, come and then drop down near x equals 8. And it looks like this graph missing on the right, but if you adjust the window, then things get better. So you really need to learn to play with the window here. I'm going to go to x max and make that 20. That should be enough. I'll make y max a little bigger too. Let's try y max be 20 and press graph and see what happens. We'll see the graph on the left, and then we see something on the right. So this is along the lines of what we thought. Okay, so the question is, what happens as x gets really, really big? And if you hit trace and you move to, like for example, we could type in 20 right now, and we get 3.58. But if we start moving to the right, what we'll notice is this thing starts to get smaller. Okay. If you press window and we say to ourselves, all right, let's go to a much bigger x max. Let's make x max like maybe 150. It doesn't have to be that, but that's usually what I pick. We see this graph definitely flattens out. What it doesn't seem to do is get close to the x-axis. Do you notice that? Remember the last example? It came down and started to get closer and closer to the x-axis? This graph doesn't appear to be doing that. And if we press trace and we type in, so for example, 100, enter, we get a y value of 2.2. We type 150, which is the max we could type in this window, we get something very close to 2. Seems to be leveling off near 2 is what's happening. Okay? So let's discuss how you might be able to figure that out. So right now, we suspect that the range is -infinity to 2, not including 2, union 2 to infinity. And I just demonstrated how you might do that on the graph. So we think the graph looks like this. With the dotted asymptote this way, that's a vertical asymptote at x equals 8. And it looks like it has a horizontal asymptote at y equals 2. I'm going to show you one thing you can do to figure things out. What I'm going to do is I'm going to take this function, I'm going to rewrite it. I'm just going to say, hey, y equals 2x plus 3 over x minus 8. And my plan is, like I discussed last week, I'm going to solve for x and see if there's anything that y couldn't equal. Is that how you did it, by the way? Okay, great. So to solve this for x, we discussed this before. Maybe you want to multiply both sides by x minus 8. Because if you do that, these x minus 8s divide out. And on the left side, you have x minus 8 times y, which we can distribute. So we get xy minus 8y equals 2x plus 3. Now it's easy to lose track. Keep your goal in mind here. What we're trying to do is get x alone. That's what we're going to try and do. So what I notice is that there's an x term here on the left and another x term here on the right. I'd like to get them together on one side while I send the y term, or anything that doesn't have an x in it, to the other side. So we put these together here on the left. We get xy minus 2x equals. And then on the right, I'm going to take these two. So this would be positive 8y plus 3. Okay, we're actually not too far away. This is a popular technique for solving. Collect all your terms on one side. Factor out the thing you're trying to solve for. I want x alone. So I'm going to factor out x and notice that there's a y minus 2 left inside the parentheses equals 8y plus 3. Divide by y minus 2, divide by y minus 2. And then all you have to do is take a careful look at the expression that you have left. You look carefully at that fraction, there's one value that y is not allowed to equal. Right? y cannot equal 2. So that is an algebraic way to figure out how come the range does not include 2.